Let's wait for a few minutes for others to join. I will start class in 5 minutes. The recording has started. Okay. Maybe we can start. So, good evening everyone. Welcome to the second live interaction session class for Matlab programming. So, this particular course focuses use of Matlab to solve the chemical engineering problems. Right. So, this is our second week class. Every Tuesday we will have this problem solving or doubt solving session from 6 to 8 p.m. Right. There is another session done by another TA which is on Friday 6 to 8 p.m. Before starting, just brief introduction about me. So I'm Bhavesh Moorjani. Currently I'm doing Ph.D. at Chemical Engineering Department IIT Bombay. I have completed my graduation from MS University Baroda, where I was introduced to this Matlab programming, which was a subject which I did as a UG student. And currently in my PhD work also I use Matlab to code and do some various analysis. Right. This are the just contact information for me. If you want to discuss any doubt outside of this doubt solving session, you can contact me there also. I will try to respond to you. So before beginning to the today's class, let's first revisit what we had done last time. So last time we did introduction to Matlab. We try to understand why we need to use modeling and simulation approach for to solve the various problems related to engineering or specifically to our chemical engineering problems, right? Now the recording of last class are available on your Swayam portal. So if you will go into the Swayam portal, as I was saying that you will have this problem solving session tab. You can click here and you can find the problem solving session recording. And once you click on this link, it will take you to the Google Sheet link where every week's lectures will be uploaded. So you will find a link, YouTube link for that lecture, right? So this was my first lecture and the corresponding material is also uploaded. So here what I will do is I will also upload the presentation as well as the MATLAB files that we will be coding during our this problem sessions, right? So I hope that is useful to you if you want to revisit with any problem. Similarly, you will find the links for other TA's material also. Okay. Now coming back to today's content. So last time we studied the importance of modeling and simulation, and we learned about the MATLAB, which is also a programming language, which has a variety of advantage over other conventional language such as C, C++ or Fortran, right? So it's kind of an object-oriented programming language with various packages and built-in libraries, which helps to ease to ease the numerical calculations that we do. So we have matrix operation, linear algebra, differential equation, optimization function pre-built, which we can use. It's great tool for graphics and plotting, data visualization. We can create our own program and scripting also, supports various toolbox, and even we can import other codes from other languages also, right? So that in the last lecture I did a short survey. So I only have got 5 response. I think these are only from the live session, and nobody from the YouTube video has voted it or filled this form. But from what I understand from this responses is that it's kind of a 50-50, that some of you are new to this coding languages or any programming language, and some of you have done some basic work in Python, Matlab and Fortran, right? And again, like, how familiar are you with this programming loops, if else loops, or programming in general? So I have got a mixed response of around 60 no, 50, 40 years. So I assume it's 50-50 if we will have a more response, right? Similarly, the rating of your class on how skilled they are in the programming. So most of you guys are beginners, right? So what I will try to focus on is, along with the problem solving, I will focus on the fundamentals of the coding part, right? So as I had said in the last class, so today's class will focus on the basic programming loops, conditional loops, and conditional statements, and the loops that we will use, how to create functions, how to do plotting in MATLAB. So that will cover the some basic stuff for MATLAB, so that you can begin with. And as we move forward with the various problem, again I will try to revisit some of the basic fundamentals, some of the basic coding part that we are using in the scripting and problem solving. The familiarity of MATLAB. So most of you have somewhat known about the MATLAB but haven't used it too much. So again, as I said in the last class, that you focus on the logic creation part, and the use of MATLAB is following the syntax, right? So if you know how to build a logic, same logic you can build on any other language, maybe it be Python or C++. Just the language, use of different language might ease up your calculations to some extent. So if I compare the C++ and the MATLAB language, MATLAB has many packages which can ease my calculation, but the basic logic that I do remains the same, right? So we will again focus on that part, and the syntax thing you can learn as you code more and more in the MATLAB, right? Another thing which I want to point out was, some of you are from not chemical engineering background. So I had one response from mathematics and someone from MSc, probably chemistry, right? So for you guys, a problem that we will be solving here will mainly focus on the chemical engineering problem. So the basic concept of that problem might be slightly difficult for you to understand, but I will try to cover the basics of that problems also, so that it's easier for you to follow what we are doing. Okay. So in today's class, we will start with the first part, which is how to define function in MATLAB, how to define our own function in the MATLAB, right? So let's begin with that. So in the last class, what we studied the common commands which are available in MATLAB to create a vector, to create a matrix, to find a complex, to find the rank of matrix, do various matrix operations, right? So this command are nothing but inbuilt function of MATLAB. Okay, so if I tell you, first let's wait for it to open up, then I will discuss. It's taking some time. So let's create one vector, right? And if I do sum of a, what it will do, it will sum all the elements of vector. Now this sum command itself is nothing but a function which is built in the MATLAB libraries, which says that when we use sum followed by a vector in a bracket, it will sum all the elements of that vector, right? So sum itself is nothing but an inbuilt MATLAB function. Similarly, we learned about how to do various matrix operations, right? So if I do determinant of A, I am getting this answers. Now this again determinant, this command itself follows a series of scripts which are in the background, which finds the determinant of given matrix, right? Or if I want to do an inverse of matrix. So these are the inbuilt functions or inbuilt script that MATLAB provides us. But let's say if I want to create my own function for some other use, which is not pre-built in the MATLAB, or I want to slightly change some of the basics function. So in that case, we can create our own function. For that, there is this basic structure to which we have to follow, which is, so all the function starts with the function syntax, which is followed by output variable. Then you have to provide function name, and in the parenthesis input variable required for this function, right? And then you do some operation on the input variable to get the output variable, and end the function, right? So this is how you create a function. So first let's try to create a function to find the fourth power of any number, right? So in order to do that, let's create a new script. So function file will start with the function, then in the square bracket you have to provide an output variable. So let's say my output variable is y. I want to provide the function name, so I want to find the fourth power, right? So I'm just writing it fourth, and in the parenthesis you have to provide the input variable. So x is my input variable whose fourth power I want to determine. Then in the next step, after that you write the operation of the input variable to compute your output. So y is nothing but 4 x to the power 4, so 4 times multiplied x, and then you end the function. So this is how we have created a basic function to compute the fourth power of any number, right? Now we have to first save this file. So when we are saving a function file, so the file name that we save should be exactly same as our function file, function name. So here you can see my function name is fourth, and the file name that I have saved is also fourth. So this is the requirement of MATLAB. If you want to create a function and save the function file name and the function name should be the same. Once we have this function ready, now if I try to run it, I will get an error because it doesn't identify what is this variable x, right? We haven't provided any numerical value, we have just created the function. But now this function has been created, so we can call it within our script or call in the command prompt to compute the values. So if I write the 4 and if you press the tab, you will see all the commands which are starting with FOR, and here you can see our function fourth is also there. If I write fourth and 2, okay, so it gives 2 to the power 4, which is 16, right? If I want to write fourth 9, so it will give the 9 to the power 4. Now when we do help and followed by any command name, so let's say I do help plot, it gives me all the basic details about the plot command, right? So similarly, when we have created our function which is fourth, so if I do help fourth, it will give me the first syntax, it will give the syntax of fourth. So fourth is a function, okay, which takes one input x and gives one output y, right? Now let's say I want to create like this plot command, I want to create the basic details of what this function exactly is, okay? So for that, if we comment in the function file, this comment itself will appear as a description of your function, right? So this function provides fourth power of variable x. I save it, and now again same run help fourth. So whatever you comment provide in the function file itself, it will appear as a help of your function, okay? Now, so this was the function file. Now once you have saved this function file, you can call it in your command window, or if I start a new script, let's say I'm writing another script, and if I do 4, you can see it's already suggesting me my function name, right? Although it's saved as a different file, but since I'm in the same path, it's providing me this value. Now let's say if I change my directory, right now we are in this folder week 2 in class where I have this function saved. Let's say I change my folder to week 2. Here also we have this function. Let's go in tutorial, right? I'm selecting this tutorial. Now since this tutorial folder does not contain any function file, if I do that, it will show me an error that there is no function file fourth, okay? So there is no command, and instead it's showing me some suggesting me some other command which I might be looking, right? So in order for your function file to work, it should be saved in the same folder as your working directory. So let's go again back to week 2's content. As I said that once you are in the same directory and your function file is also in the same working directory, you can call that function. One thing which you have to understand that so function file is nothing but another type of script file which starts with the word function, and the file name and the function should be the same as the function name, okay? We cannot run the function file, but we can use it in the command window and other script to call a function. Now here, let's say if I change the file name, instead of fourth, if I try to write some other name, let's say my name, okay? And when I call the function now, so it doesn't show me any function because now the file name and the function names are different. So it's not showing me any value, right? So your function name and file name should be the same. Here. Now again, if I see, you can see I can find the function. So that is one requirement. Now you can use a comment to provide a description or provide the help about your function that you have created, right? Now when it comes to the function file, any function that we are using, so position of function in a normal script and a function file varies. So if you have followed the source class, you must have seen that when using an Euler's method, he's creating a function at the bottom of the file while the top part contains the normal scripting. So if I want to create a function within my script file, the position of the function becomes an important part. So what I mean by that, for that let's look at this example. Yeah. No. Yes. Okay. So I have this function which creates, which converts 2D cylindrical coordinates to Cartesian coordinates. So we provide the radius and the angle value in the radius value and the angle value, and it provides me corresponding Cartesian coordinate, which are r cos theta and sin cos theta, right? Now let's say if I have this same function, but instead of saving it as a function file, I want to call it within my scripting. So let's say this is your script which has some operations that you have done, and in between you have to call your function where I am defining variable a, b, and I am calling cart 2 comma 5/2. Okay, and now when I run this script, now when I run this script, you can see I'm getting the value of a and b, right? So this is pi/2. So cos pi/2 is 90. So cos 90 is close to 0. So you are getting e to the power minus 16, and sin 90 is 1. So let's say if I do pi/4 and run it. So same function, but now we have provided it at the bottom of my function, bottom of my script file. So in this case, my script file can be of a different name than the function file, and it won't show any error. But if I try to start the same file with a function, and run it, I will get an error because first line starts with the function itself. Okay, so this statement is not inside any function. Line 7 column 1. So it says my function name, I'm starting with the function cart, while my, so first line is itself is function, so this is comment, then it's function, and it observes that my function name and the file name is different, so it rejects it. So when you are creating the function, if you are creating the function in between your script, you can place it below your scripting. But if you are creating a function as a separate file, then only it can go to start, and your file name and the function name should be the same. Right. So the naming convention when you are using function in a script file versus function file is an important part that you have to pay attention to. Okay. Anyway, you will get an error, so you will get to know it, but this is a good practice to understand what is happening and why these errors are coming. So now let's solve some problem related to creating a function. So first problem is creating a function file to find the specific surface area of cylinder. Now what is specific surface area? So, okay, I have only one student. Do you know? Sorry, I cannot pronounce your name. Silva Subarshi. Do you know what's the specific surface area? So it's surface area per unit volume, right? So for any 3D object, if we divide its surface area by volume, then we get a specific surface area. From a chemical engineering perspective, when we are talking about the solid catalysis, when we are talking about packings inside the reactors, then you come across this term of specific surface area. It's also used in the heterogeneous reaction engineering part, where the you either provide your rate kinetics data in terms of catalyst mass, catalyst volume, or surface area, or maybe specific surface area. So it's again important aspect of us for us in the as a chemical engineering in the designing aspect. So in your code, at some place you might encounter a part where you have to compute the surface area for your cylindrical pellets, right? Cylindrical pellets or packings. So for that, let's try to create a function. So I will create a function which is, this is my output variable, surf area. This output variable name can be anything, okay? This is your naming convention, and when you are calling the function, it doesn't have to match with the variable name that has been mentioned in your function, right? So this is just this variable name is important to this function file only and nothing else. Here you can provide the output name in a square bracket or without square bracket also. When you have more than one variable in your output, then in that case you have to provide your output variable in the square bracket, else it's fine. Okay, so let's call this function as SSA, which is specific surface area. Now to find the specific surface area of cylinder, what parameter we will need? We will need geometric data of my cylinder, which is radius and the height, right? Now once I know the radius and height, first what I have to create, I have to find the area. So total area of cylinder, which will be both top and bottom circles and the periphery, right? So that will be 2 times pi r in bracket r plus h, right? So this is my area. What will be the volume of cylinder? Pi r square h, right? So pi r square into h. Okay, so this gives me my volume, and then my specific surface area is nothing but area divided by volume, and then you end the script. When I do Control S, you can see by default it's showing me the name of the function SSA, right? So specific surface area, and thus my function has been created. Now when I call this function SSA and add the value, so I will get the answer, right? So this is the specific area of this cylinder, which is its area divided by volume. Now here the format of the function file, it doesn't have to follow the specific naming convention, right? So here we have written function as output variable, then function name, and then input variable. I can create a function without an output variable, okay, and without an input variable, that will just print hello and I can save it. Sorry, let's save it. Let's write it as hello. Okay. So when I call a function, there is a error in syntax, printf. So when I call the hello, unrecognized function FPRI, printf, so it will just print the hello, right? So it doesn't mean that function, so this format that we have discussed this is not a strict format that you have to provide output variable, input variable. You can just call the function and define variable in between also. Okay, so you might not have to rely on the input variable all the time, right? Similarly, your output variable, it doesn't have to be one value, it can be a matrix value also. You can add this value as you go ahead. So for example, so we will come to that also, that example. Let's focus on the other example. Now second is create a function file that takes the user input temperature in degree centigrade and converts it to degree Fahrenheit. Now such conversion might be encountered when you are doing some calculations, right? So some of the conventional property calculation part, they follow the other units also. So in that case you might need conversion, which is a common aspect. But here what it has said that create a function which takes user input as a temperature. So we need something which takes the input from the user as a temperature and then converts it into the degree, that converts that temperature into degree Fahrenheit, right? So for that we will use input command, fprintf and display command. So let's create this function. So normally what we will do, we will create a function. Now my variable is temperature in degree Fahrenheit, so I'm writing it as f. I'm calling this function as Celsius to Fahrenheit, where input variable will be C, which is temperature in degree centigrade. Now normal conversion follows. F is equal to, so to convert degree centigrade into Fahrenheit, you do Celsius into 9/5, right, plus 32, and then you end it. So first let's check this function, which is C2F. I'm adding temperature as 30 degree centigrade, and it gives me this value, temperature of 35, which is 90, 40 degree centigrade 104, and 0 temperature, which is 32 degree Fahrenheit, right? So this code is working, but here I have been asked to take the user input as a temperature. So for that we will use input command. So if you will search help input, so input command, it asks for the user input. So we can write, this is an sample example, input, and in the your single quotation you can write whatever message you want to put. Okay, so do you want more, yes or no, and then you take its answer. So if I type a is equal to input bracket, I can write some comment, enter number between 0 to 10. So it will ask me to enter any value, and I provide it. So I have entered 9 and it is saving it. Okay, so we will use this part of an input. So here we don't need temperature to be provided when I'm calling C2F. So I'm removing the input variable and I will call the temperature from the input. So I will ask the user provide temperature in degree Celsius. Okay, once user provides that input, that will be considered as C, which will be used to convert into F. Okay, so now when I run this function, it is asking me to provide a temperature. So I am providing 0 degree centigrade and it's giving me the answer 32. Now but what is this 32? I don't know. I want some description for my answer also. Okay, so for that, instead of providing the output as an answer, I can write the output. So what we will do, we will use fprintf command. I also used it previously, but let's learn about this command. So this is used to print the value on your command prompt or inside your file, right? Printf. So this fprintf writes the formatted data to a text file. So either you can use this fprintf command to write or display the output in your command file, or the save the data inside any text file. Okay, sir has already shown about this in his videos, so I'm not going into too much detail. But if you will go into the documentation, then you will find various customization in this fprintf command. Okay, so how to provide integer value, how to provide fractional value to if you want to control the decimal data after that decimal data that you want to print in. So you can use %f, so this %6.2f, as such notations you can provide. Okay, so the detailed description is given here, you can see, and you can learn about this also. So here what I want to do is I want to print my data from fprintf. So I will do fprintf temperature value in degree Fahrenheit is, now this data within the single quotation is a comment, so it's a string file that will be printed, but my f value, which is a variable, right? So if I just put f, this will consider it as a string and it won't put any data. So instead I can use this %f comment. Corresponding to this, we have to write the variable name f, and that will print the value. So provide the temperature. So temperature value in degree Fahrenheit is 32. Okay, so this is how you can control the output. Now to show the output for the printing part, I have used fprintf. There is this another command which is disp command. So if you will see help disp, this displays the array. So disp x displays array without printing the array name or additional description. So same thing we could have done here also. So instead of writing this, I could have written that fprintf temperature value in degree Fahrenheit is this. This /n notation means it will go to the new line, and then I do display f value. Now here I don't have to worry about the precision, it will use its default data. So 30 degrees centigrade I am providing. So temperature value in degree Fahrenheit is 86. Okay. Now the difference between display and fprintf. So disp command is specifically used when you want to display your vectors or matrices. Okay, so let's say I have a vector A with some data points, or let's say it's a matrix, right? Now when I do disp A, it will display the same matrix as it is in the matrix form. But if I do fprintf and provide %d with this, so it will print. So same again, it's printing the element, but it's printing each element together, right? 3253 645, which is not convenient. You can modify this fprintf command. I can provide tab at each value, then it will print them separately. Again, you can modify it to create to show it in the matrix format, but then again it's a much longer struggle. Rather than I can just directly use display command to show the show the vector or matrix, right? So this is the basic difference between fprintf and display command. So display command is basically useful to just show the to show matrix, to show the vectors, while fprintf is generally useful for normal like string printing and writing inside the file. Okay, third part is create a function to compute LMTD of a heat exchanger. Now what is LMTD for a heat exchanger? Do we have a student? And do you know what is LMTD? No. Ah. So LMTD is a logarithmic mean temperature that we use to find the mean delta temperature between hot side and cold side fluid, right? So if you will search LMTD of heat exchanger, it's a logarithmic mean temperature which determines the driving force for heat transfer between hot fluid and the cold fluid, right? So to compute the LMTD, we should know the four things. One is the inlet and outlet temperature of hot side fluid, inlet and outlet temperature of the cold side fluid. So we need four temperature data. From that we can compute the LMTD, which has this formula. So here delta T1 is temperature difference between inlet and outlet fluid in one side and temperature difference between inlet and outlet fluid on the other side, right? So let's try to create the function for that. I will create a function which provides me the temperature value. Let's name it as LMTD. Now we will need a 4 input, right? Hot side inlet temperature, I am referring at TH in. Hot side outlet temperature, TH out. Cold side inlet temperature and cold side outlet temperature. First I have to compute temperature difference at one side, so I am calling it as delta T1, which will be PH in minus TC in. Second side delta T, which is TH out minus TC out. Okay. Then my LMTD is nothing but delta T1 minus delta T2 divided by log of delta T1 delta T2 and ND file. Let's save this function, and when I'm do LMTD, I have to provide the 4 temperature value. So let's say hot side inlet temperature is 80, outlet temperature is 60, cold side inlet temperature I have cooling water at 25 degrees centigrade, chilled water, and it's leaving at 30 degrees centigrade. So this is my LMTD value for this specific inlet outlet temperature. Now here, this LMTD, there is one issue with this LMTD data, right? So this LMTD that we have calculated is specifically for one flow condition only. So in a heat exchanger, you have a co-current and counter-current flow, right? And depending upon what type of flow you consider, your LMTD will vary. So for example, right now what I have considered is a co-current flow where both hot and cold fluid comes from the same side and leaves on this other side. So for that, delta T1, which is our inlet temperature difference, is hot in minus cold in, and delta T2 became hot out minus cold out, which I have used. But what if I have a counter current flow? In that case, hot side inlet and cold side inlet are different, so my delta T at one side is different, which is T hot in minus cold out, and delta T2 is hot out minus cold in. Okay, so in that case my LMTD is different, but I haven't provided any conditions here to find to see what kind of LMTD I am computing. I am just assuming it's a co-current flow and I am computing the LMTD, right? So how to encounter such cases? We will come to that when we are learning the decision statements in the next part, right? Another example is create a function file to convert Cartesian coordinates to a cylindrical coordinates. This I have already kind of shown you, but let's see. So we have Cartesian coordinates, so it's x, y, z, and we want to convert it to cylindrical coordinates. So what are the cylindrical coordinates? Let's search for that. Cylindrical coordinate system, right? I want some formula for that. No, not this one. Wikipedia should help. So this is how cylindrical coordinates look like. So if I have a Cartesian coordinates, which is coordinates in 3 dimension x, y, z, I can relate it to the cylindrical coordinates. So for cylindrical coordinates, you have rho, phi, and z, right? So this rho is nothing but your radius. So we refer it r, and then phi, which is an angle, and z, which is your z dimensional distance, essentially same, right? So if I have Cartesian coordinates, how I can, with the help of this formula, can you create a function which provides you back the cylindrical coordinate? It should be easy, right? So I'm leaving this as a practice problem for you. It's fairly straightforward. So you will have a 3 input which will be x, y, z coordinates, and 3 output data which will be nothing but r, theta, and z value. Okay, so you can use this formula and convert your Cartesian coordinates to the cylindrical one. Okay, I try it out. It's fairly simple, so I'm leaving it up to you. Now this was to define functions within your Matlab, so creating your own function, modified function for your own set of calculations, right? Now when we talk about Matlab, last time we learned that Matlab is an interpreted language. That means each command is executed line by line. Okay, so if you will look at any simplest .m file, it will perform instruction sequentially, so one by one each command will be followed. But however, there is a need of non-sequential code sometimes. What do we mean by that? So for example, when we computed the LMTD, right? Now LMTD we computed based on considering the co-current part, but let's say the flow was counter current. In that case, the co-current part calculation, I don't need it, I want to skip it. Or oftentimes in the fluid phase, based on the Reynolds number, what kind of regime you are, whether you are in the laminar region, whether you are in the turbulent region, you have to use different set of equations to compute your pressure drop or any fluid properties, right? So in that case, you need some decision variables. Based on that, you can decide what part of code to execute. So that becomes a non-sequential code, and that can be achieved by 2 types of statements. One are decision statements, which is done for a selection of a part of code which we want to execute, and then loop statement, which are for a repetition. So it will repeat a calculation till a certain point, till a certain condition or certain point requirement is met or not. We will come to that also. So this programming as a whole, with the help of such decision statement and the loop statement, is called as a structural programming. Okay, so the essential part of the structural programming are decision statements and the loops. So decision statement contains if structure, if else structure, if else if structure, and switch structure. For loops, we have 2 basic types of loop: for loop and while loop. We will see all of this and some examples related to this loops also. So first, let's look at the decision variables or decision statements. So for decision statements, we have 4 types of basic structure. One is if structure. In the if structure, we provide one condition. If this condition is satisfied, then only this statement followed by that condition in the if loop will work, else it will bypass this statement and go to the next part of the code. So this is generally used, let's say, if you are performing some numerical operation where you want to turn the negative sign of a variable to the positive. So if the sign is negative, then only turn it to positive, else the skip that statement part, right? Okay. Or you want to do some operation on a even number variable only, in that case you can provide some condition, it will do the operation. If the number is odd, then we have to skip that in between part because it's not needed. Similarly, if we have multiple conditions on our variable, then in that case, instead of using if statement, so here if the condition is true, then only this statement will be followed, else it will skip. You can provide if else condition also. So if condition is true, you will follow one statement. If condition is false, you can follow the other statement. Then you have multiple condition loop, which is if else if. So here you provide multiple conditions, so your code will run when it will come into if else if structure. It will look for all the conditions. It will check if the condition 1 is satisfied, it will follow the statement 1. If not, then it will check for the condition 2. If that satisfies, then it will execute that part and the loop will end. If not, then it will look for the third condition, and so on, right? So here in the if else loop or this if else if loop, if any condition is missed, then the bottom part of that code is not executed, right? So if my condition 2 are met, then I will perform statement 2 and rest will be ignored because I have already satisfied one condition. I am using statement of that and then I am going ahead. Okay, so I don't need the further conditions. Okay, so it's kind of either this or this type of a statement, right? We will see example of this statements, then it will be more clear to you. Another type is a switch structure. So switch structure is basically based on any one variable. So here this conditions can be any logical condition, so it can involve multiple variables and it operates on that logic. Either logic could be 0 or which is false, logic could be true, which is 1, right? But instead, if I want to execute my conditions based on a value of particular variable, then I can use a switch statement where this test variable condition will be checked for different cases. Whichever case it will meet, the statement for that will be followed. So it's kind of similar to if else statement. I will show you via one example here. So let's look at the example first. Let me see. LMTD plot. No, this is a plotting part. Factorial Fibonacci. Heat transfer coefficient. So here we have some practice problem also. So first is write a code to check if a number is divisible by 3 or not. So in that case I have to check if a number is divisible by 3 or not. So here we have not been specified whether we have to create a function or whether it's part of a scripting. So we will try to code it as a script, okay, and see. So we will ask the user to provide an input variable, and then we will check whether it's divisible by 3 or not. Okay. Just a minute. So let's say first we will ask a user to provide a number, provide a number that we will store as an input n, input variable n. Now if I want to check if n is divisible by 3 or not, so how we will do it? Like when we are saying divisible by 3, it means that when we divide any number by 3, its remainder will be 0, right? So for that, if you will recall, in the last class also we looked at this ram command, right, which finds the remainder of a number when it's divided by the second number. So if remainder of 8 by 3, it should give me 2, right? Remainder of 7 by 3, it gives me 1. So if remainder of any number followed by 3, if is equal to 0, that means it's completely divisible by number 3, right? So this is my basic logic that I want to follow. So in that case, I have two statements here, like two conditions. If remainder is 0, that means number is divisible by 3. If not, then number is not divisible by 3. So in that case, from all these 4 loops that we have seen, I think this one, if else statement fits perfectly, right? If condition 1 is satisfied, that means, like if remainder is 0, that means number is divisible by 3, else it's not. So this statement works best, so I will use that. We will check if ram of that number divisible by 3. Now I want to compare it. So for compare, we have seen these logical operators previously, right? So equal, not equal to, greater than, greater equal to, less equal to, right? So if I will compare, if this is true, then we will print that the number %d is divisible by 3. Now provide n. Okay. Else number is not divisible by 2. I can save it. Okay. Division. And when I run this code, first I will be asked to provide a number. Let's say I provide 11. 11 is not divisible by 3, right? Again I can run the code by calling the file name. Let's say this time provide 12, and 12 is divisible by 3. Okay. So this is how you can create your own short functions or short conditional loops also. Okay. Now this is just a practice problem. You won't find such basic statements inside, but based on your problem statement, you will have different more involved conditions here. Let's look at the if statement. Here, same example, if I use, but if I only use if condition and I end it, so it will only check one part, whether it's, so see, here I have provided 11, which is not divisible by 3. So I'm not getting any output here because I don't have any else statement. If the number is divisible by 3, then only I will get this statement, right? I think it's divisible. Then only I will get this statement. So if condition number is 9, it's divisible by 3. Okay. So this is an if else loop. Now when you have multiple conditions, you can add more conditions by else if commands. Okay, we will come to that in the further next example also. Let's look at the second problem that we discussed previously also, where we computed the LMTD of an heat exchanger, but that was based on the considering only one flow condition, which was co-current. Now I want to include condition check, where first I get to know whether the flow is co-current or whether the flow is counter current, and based on that only I compute the LMTD part. So for that, let's create a new function file. Function t is equal to, now I will call it as modified LMTD. Okay, so we have hot fluid inlet temperature, hot fluid outlet temperature, cold fluid inlet temperature, cold fluid outlet temperature, and then I can provide one more variable. I am calling it as flow condition. Okay, here let's put a comment also, that provide inlet and outlet temperature of hot and cold fluid respectively. Just I'm denoting for user, I'm writing this comment for the user. I'm saying them to provide hot and cold fluid temperature, so first inlet and outlet respectively, right, along with flow condition. Now what I have to check first is what is the flow condition. Once I know the flow condition, then I can use the relative equations to compute the LMTD. So first I will check if flow is co-current or not. If the flow is co-current, then the previous function that we had defined, we have used previous calculation that we had done in the normal LMTD function, I can use them, right, which was delta T1 is equal to T hot in minus T cold in, delta T2 is equal to T hot out minus T cold out, and my LMTD is delta T1 minus delta T2, which is divided by natural log of delta T1 by delta T2. Okay. If not, then I provide another condition, which is else if the flow condition is, it should be equal to, because we want to compare, right? If the flow condition is counter current, in that case my delta T1 and T2 will vary, it will change, right? So my delta T1 will be TH in minus TC out, and this will become TH out minus TC in, right? So this is following the equation that we already discussed. Not here, this part. So for the counter current, what I am doing, delta T1 is hot in minus cold out, delta T2 is hot out minus cold in. Okay, and then you can end this. So this is your function has been created. Now let's call the previous function first LMTD. So here now I have one. So previously we got the value of LMTD as 41.24 for the co-current flow. Now I want to see what is modified LMTD. So for that I have to provide the inlet outlet temperature of hot and cold fluid respectively along with the flow condition. So I will use modified LMTD, provide the same condition 80, 60, 25 30, and then co-current. Okay, first let's check with the co-current, and I'm getting the same answer, right? Now if I had a counter current flow, then my answer will be different. Here they are fairly close, but in some cases you might get a different values also, right? It will depend upon your temperature conditions. So here we have modified this LMTD to compute LMTD based on the flow conditions. But here we know this is my own code, so how to write co-current and counter current, and it's exactly matching that string that I have provided co-current with this condition. Let's say I don't know how to exactly write co-current or counter current. I don't know if there is a dash or not. I'm just writing it this way. It's doing nothing, okay? Because here in my function itself, it is using this decision statements. So first it's checking with the flow condition is equal to co-current. If yes, this is how you compute delta T. If not, if it's counter current, then this is how you compute. If not, then it will end the function. It's not giving me any error, it's not giving me any value at all, right? So as a user, when I do this, I don't know what has happened, okay? If you have created your own function, you know how it is working. But for somebody else who might be using your code, it's better to provide a description. So that's why we provided description as a comment, but still it's not clear how to provide the flow condition. So it's a good practice to add more description to your code. So here we will add third condition, which will state that the user input is incorrect. The flow condition provided is incorrect. Okay, slash and new line. I will inform the user that flow condition can be either of two, because I want them to know so one condition is co-current, right? So this is important because here this condition are matched with the string variable, which is case sensitive. So if someone writes co-current with a C small, lowercase c, then also it won't execute. So in that case, you have to let the user know what exactly they have to provide as an input. Okay. Now when I run the same script, it shows that the flow condition is incorrect. Okay, it could be either of two, co-current or counter current. Let me put slash n here. Slash n. Right. So this is how the user knows, okay, I have made a mistake, I should put a dash in between, then I will get the correct value. Or you can provide a more better description of a code, right? So all the as I mentioned earlier also, that all the commands that we are using in the Matlab are nothing but an inbuilt function, right? So when I'm computing the determinant of a matrix, when I'm doing determinant of A, so this is a square matrix, right? I can find its inverse also. But if my matrix A, let's say it's not a square matrix, in that case if I do inverse of A, I am getting this error which says error using inverse, matrix must be square. So this is nothing but a inbuilt Matlab function which has this check which first look at the matrix and determines whether it's square matrix or not. If it's not square matrix, then we cannot do that operation, and it gives the user a warning that matrix should be square. Similarly, when you are creating your own function and when it will be used by somebody else, it's a good practice to write this to provide more and more information, to provide this check for the errors also, so that other users can also know what exactly you are doing in your code, how it is being executed. Then okay, so I hope this is helpful. I have okay. If you guys have any doubt, please let me know, since attendance is low and people are coming and going. I'm not sure how many people are there. So if you have any doubt, you can stop me in between also, right? I hope this exercise is helping you to get very basic idea of how to use function and loops. We will do chemical engineering related problem down the line also, right, from the next lecture onwards. But right now I want to build a base for those who are new to Matlab completely, or those who have worked some part of Matlab, right? Because in the response also some people were asking, like based on the response I understand that most of you have a basic knowledge and want to understand how to do more coding part, how to do application part. So that we will come later, but right now first let's create the base. Okay. Then next exercise problem is, which says create a program to compute the heat transfer coefficient based on the flow condition of fluid, which is also provided by the users, right? So two basic heat flow conditions are laminar and the turbulent, right? And if you recall your heat transfer class phenomena, then if we have a laminar flow, then there is an equation which is Cedar-Tate equation for the Nusselt number. If you have a turbulent flow, then we have a Dittus-Boelter equation for the Nusselt number. And then from the Nusselt number, which is your heat transfer coefficient into characteristic length divided by your thermal conductivity, you can back calculate the heat transfer coefficient, right? So this is the basic equations that you have used in the heat transfer part, or maybe design, or maybe in the designing of heat exchangers, right? So based on the flow conditions, you determine the heat transfer coefficient. So first let's recall that two equations which we were talking about. So one is Cedar-Tate equation. I think it's here. Yeah. So if you have a laminar flow, so it will be determined based on the Reynolds number, right? So if your Reynolds number is less than 2000 or 2100, whatever you follow, then you can use this equation to determine the Nusselt number, and your Nusselt number is nothing but Hd by K, right? So if you have the diameter, if you know the thermal conductivity of the fluid, then you can compute its heat transfer coefficient, right? If you are in the turbulent regime where your Reynolds number is greater than 4000, then you can use the Dittus-Boelter equation to compute the Nusselt number and then back calculate the heat transfer coefficient, right? So we will use these two simple conditions as of now, and then follow the and then compute the heat transfer coefficient, right? So right now I am only asking, we will take the user input. So one is obviously Reynolds number is needed, then second we will ask for the Prandtl's number, we will ask for the diameters and the thermal conductivity. We won't be including this part, since I just want to know how to create the basic loop structure. You can add further modifications, different equations, various conditions in between also, to make your code more robust. But right now we will focus on the basic part. Okay, so I want to create heat transfer coefficient script to computing the heat transfer coefficient, right? I have already one script ready. So this is how the basic structure will look like. We will ask user to provide some input. We will check the flow conditions, and based on the flow condition we will compute the heat transfer coefficient. So here I can ask, first let's ask for the Nusselt number. So I'm asking input user, sorry, not Nusselt number. First we will ask for the Reynolds number. Reynolds number of a fluid. Prandtl's number. Reynolds, Prandtl's. We need diameters also, right? So that is provide diameter of a flow pipe. What else we need? We need a thermal conductivity, which is input provide thermal conductivity of a fluid. This four input variables we need. Give me a minute. So I have two equations here, one Seidel-Tate, one Dietz-Bolte, and that will be decided based on the Reynolds number condition, right? So here I will use if else if commands, right? So first I will check if Reynolds number is it less or equal to 2100, then we will inform the user that flow is laminar Now, once we know the flow is laminar, we will compute the Nusselt number, which is 1.86, Reynolds number raised to 0.33, sorry, yeah, 0.33, Prandtl's number is raised to also 0.33. So, into now once I know the Nusselt number, I can compute the H by into K by T. Right? So you have Nusselt number is Hd by K, so H is equal to Nusselt number into K by D. Right? And this is how you compute your heat transfer coefficient. Okay. This is for laminar condition. If my Reynolds number is greater or equal to 4000, then I will print that we are not in the laminar region, but we are in the turbulent region. So flow is turbulent. We will put that comment. Then here my Nusselt number equation changes to 0.023. I will use for this formula for non-viscous liquid. So 0.023, Reynolds number is to 0.8, Prandtl's number is to 0.33. 0.023, Re raised to 0.8, and this is 0.3. And the again same part, right? And then I can close this if else statement. Okay. Heat transfer coefficient. We have computed this. Now we have to provide user this information, which is we will provide it by fprintf statement. The heat transfer coefficient of a fluid is let's say /t. I will provide tab, then %f h. Okay. When you run this command, Reynolds number. First let's look in the laminar condition. I'm just providing the arbitrary value so it won't be correct. Diameter of pipe, let's say 20, thermal conductivity 100, and I'm getting this as a heat transfer coefficient, right? So flow is laminar and the heat transfer coefficient is 724. Let me do some modification here, slash n, somewhere we have not provided comment here, and again now let's work in the 10,000. So we are in the turbulent region. Prandtl number 400. Again, this is an arbitrary part. Okay, it has nothing to do with actual values, but this is how you get the data. Okay, and now oftentimes when you are running a script, you will see like here, most of the time the script starts with the clear all and CLC part, which is to remove any previous variable which you will have in your system, so as the previous data does not interfere to your code, right? So if I do clear all CLC, if I have kept this and I run my code, then you can see all things has gone away and it should be clear all, right? Clear all. Hmm, 20, 100. I have tested 2 times. So it has removed all the previous variable and now I have only this new variables, right? So this is a better practice to do, so that if there is previous same variable that you have already defined, it does not interfere with your new code or script file. Okay. So this was some example based on the decision variables or which decision statements. Now here I haven't provided the example of switch structure, but you can consider switch structure as if-else if structure, but the condition here will be the exact equality condition. So in the switch variable, like switch loop, you do test variable if it has a value 1, that means is equal to some data. So it can become condition 1, test variable equal to 1, then you provide the statement. If not, then else if, you look for the other condition. So here in the if else if part, if my conditions are equality conditions, then it becomes a kind of a switch loop. Okay, it's just a different options that you have as a decision statement that you can try on. You can check any example also in the web or some book, you will find it. Now next part in the structural programming is looping. So there are mainly 2 types of loop that we use, for loop and while loop. So what does this loop do is it starts with some index value. So like for for loop starts with some index. It has a start initiation value, it has a step value, and once it reaches the finish value, till this the statement inside the for loop will be repeated, right? So let's say I start with index 1, step 1, and finish value is 10. So my index will go to 1, it will run the statement inside the for loop, then my index value will change to 2, it will run the statement again, then index value will go to 3, run the statement again, till my index value reaches to the value 10. Okay. Now contrary to this, in the for loop we provide the condition that index goes from 1 to 10, till this time you have to repeat your loop. But in the while loop, instead of providing any index, we provide the condition. Till this condition is true, my statement inside the loops will be repeated. Till this condition is true, my statement inside the loop will be repeated. Once this condition becomes false, then I will be out of the loop, right? So let's look at some example and see how exactly this works. Okay, so we have one example which is compute and provide the factorial of number based on your own code through for and while loop. Okay, so I have to create a script to compute the variable, compute the factorial. So first I will ask a user to provide me a value, provide a integer number, since we want to compute the factorial, right? So what I will do, I will compute the factorial with for loop also and while loop also, so that we can compare how exactly it looks like. So first is using for loop, my fact is equal to, I will start with value 1. I initiate the for loop. You can provide any index, so this variable is specifically for your for loop only. It can take any, you can provide I, j, k, your name, anything. You have to start one value which is initiation, step size, and then end value which is n. Okay, if you don't provide 1, by default it will take a step size of 1. Okay, if you want to change your step size, then in that case you provide in between value also. So now how do we actually compute the factorial, right? So factorial of 3 or factorial of n is given as, we do 1 into 2 into 3 into 4 up to we go till n, and this gives us the factorial, right? So I start with the value 1. I'm moving forward with this for loop. I'm moving forward till n part. What I will do, at every step I will change this value. Fact is equal to fact into my I, then I do end. So what is happening here, fact will start the value 1, it will update the value fact into fact, which is 1 into 1, then it will have, I will have a value of 2, increase in step size, then it will multiply 1 with 2, 1 into 2, my factorial value will change to 2, then I will go to 3, my factorial value will change to 3, so 2 into 3 which is 6, right? So this is how we update this step. If you want, you can print value of %d slash n. So I'm printing value of I also, so that you know how it is changing, and at the end I can show, right, printf factorial from for loop is I will do this fact. You can provide the value in the fprintf command itself. So this was using the for loop. Now same thing I can do with the while loop also. So here what I will do is I will use the while loop. Now for the while loop, I know I have to start with 1 until I go to the value n, okay, which is provided by user. So if I say while I is less or equal to n, so I have to provide initiation value of I, which you generally do outside your outside your while loop. So while I is less than n, you have to do fact is equal to fact into I. Now here in the for loop, I value changes by itself when it reaches the end of a for loop, but in the while loop you have to update your test variable or the conditional variable that you are using, else what it will do, I is equal to less or equal to 1, this condition will be always satisfied, and it will compute fact into fact, fact into fact. So that means you are forever in the while loop, right? But if you want to break the while loop, that means you have to once this condition is dissatisfied, then only that can happen. So here we have to update the value of I manually. So I am using that. I can again print the value of I here just to see how it is changing, right? and then your printing statement, factorial for while loop. While loop is okay. Now let me provide clear all CLC command, and now let's run it. What happened? Using factors, both name and variable. Okay. Yeah, so I have fact as a variable also, so it's not allowing me. So let's rename it to factorial of n. Okay. Yeah. Now let's run it. So when I run it, it's asking me for a user input. So 4. So we know 4 factorial is 24. So 2 3s are 6. 6 into 4, which is 12. Right? So if I do with the for loop and while loop, I'm getting the same answer, but the method that is followed is slightly different, right? So for for loop, it will start with the value 1, right? So here fprintf I is equal to 1, it is computing the fact. Then when it reaches the end of the for loop, I value will change by itself. It will go to second, third and fourth, right? But for a while loop, first I value is 1, then we manually change the value of I, right? If I don't do this, that means if I comment this, we will be forever in the while loop, because this condition, when will while loop break? Once I becomes greater than n. So when we have I is equal to 5 and n is equal to 4, right? So this condition broke, and thus we got free from the while loop. If I don't do that and run this, you can see I am forever in a while loop, right? So when you are using the while loop, you have to make sure that you reach a condition where your while loop stop itself. If not, then you have to provide some check or some other conditions to see whether your while loop breaks or not. Okay. So for that, there are some in between commands that you can use. So there is this break command, which is used to terminate the loop in between. Okay. We will come to some example of that. Then you can use the pause command to halt the loop. So let's say if I can put, once I compute the factorial from the for loop, I want to pause my code, so I can do that. Why unrecognized? Oh. Probably some syntax error. Sorry, command is pause, which is to halt the loop. My mistake. This is a pause command. Yeah. So if I do that, it will compute. So it has done calculation till the for loop, and then after that the script has stopped. Okay. Now if I want to further continue, I have to again do run. Then the second part will be completed from here, right? So So I computed with the for loop. If I press the enter, then only the second part is completed. So this is useful when you are doing much longer code and you want to check till what point your code is working. You can also keep a timing of how long it takes to run your code. For that you have this tick tock command. So if I provide the value of tick at the start, tick here, and talk at the end of a file, okay, and if I run it, let's provide much higher value this time. Let's say I want to compute the factorial of 35. So it took a 8.22 seconds. I had a pause loop here. So let's see, I'm removing it. So it computed this entire thing into 2.3146 seconds, right? So this is generally useful when you are doing much longer code and you want to check optimum speed of your code by doing various manipulations. So such cases you can use tick-tack command also. Break command, I haven't shown you example, but you can put the in between condition. So let's say if in a for loop, if I put some condition that if n is equal to, let's say I want to compute n value till factorial value till 100 only, right? So I can put a condition in between that if n is equal to 100, or if I becomes here I is equal to 100 equals to 100, then break the loop. So in that case it will break the for loop, right? Let's look at the other example. So we have two example and then some of the plotting part and quiz also. So what I will do, I will do this code of trapezoidal rule only. You can try the Fibonacci series code by yourself and see. It should be easy because I have other material to cover. We will see some plotting example and then quiz part. Okay, so let's do problem set 2, which is asking us to write a code which finds area under the curve of a given function between two limits using trapezoidal rule, right? So I assume you guys know the trapezoidal rule. So trapezoidal rule is it's used to compute if you have a function and then you want to do numerical integration to find the area under the curve of that function, then you can use trapezoidal rule where you discretize your function, your function between the two limits, and for each limit you compute the area, and at the end summation of that area gives you the total area under the curve. Similarly, you have Simpson's rule also to compute the area under the curve, right? So we will use this trapezoidal rule here to create to find the area under the curve. For that, so I have one sample example already ready. Don't worry, we will do our own code also. So here, first I am providing the function. So we haven't been said to provide what kind of function to use. So I'm using function x square. You can use any function. So we show the function how to define the function. So there is this another option to provide the function through function indentation, which is, if you can write it in this fashion, this also creates a function, right? This creates function of x which returns the value of x square. You define the lower and upper limit, number of in between division which increases the accuracy, the h step size between the two limits, right? So if I am increasing the number of division, my step size goes down, which increases accuracy, but then my computational power will be more, because since I will be computing so many things, and I'm using the for loop, right? So first let's look at the equation of the trapezoidal rule. So to find the area under the curve, what you have to do, you do dx by 2 function at start plus function at end, function value at the end, and for in between value you take the twice the function part, right? And this delta x is determined, the step size is determined by how many number of points you want to take in between. So we have to use this formula. So let's do this. What I will do is I will copy some part from here. Okay, let's look at x cube. I'm using this time x cube function, right? Provide a limit in between where we want to find the area. Okay, I'm commenting this for two reasons. One is obviously when you will guys refer to this, you should be able to understand this, and another is when somebody else refers to your code, or after a certain time when you revisit the code, it should be apparent to you what each variable represents, what kind of conditions you are using, right? Then number of steps to do steps. Okay, let's just keep it, and let's say initially I want to do 10 step only. Based on this, I compute the step size, which is h is b minus a by n, right? Then now we compute the area. So I have some area, I start with the value of 0. What I have to do, so for in between data points, initially at f is equal to xa and f value at xb will be the only one, but in between I have to take the twice the value of a function, right? So what I will do, I will run a for loop from x is equal to 2 to n minus 1 part, okay, and then compute the 2 times f, which we will add as a summation, and at the end we compute the area. So for I is equal to, I will start with the 2 1 n, okay, I compute sum area is equal to 2 times my function into I, right? So first is x cube, so I will start with 2 cube, 3 cube, that will be added twice. So sum area and then my overall area, that will be sum of area function at a plus function at b. Sorry, here it will be, it should be b minus, I'm starting with 2. Just a minute, it should be, so we are starting with a equal to 0, I have to go till b equal to 1, step size should be h, A plus H, B minus H. This is how it should be, right? This yeah, so this we have to multiply with our H by 2, okay? So H by 2 here, right? And at the end I can display the area. You can print it as f printf area under the curve is, right? So this way, let's stop this out. So it has computed the area under the curve based on 10 data points only. Now let's say if I increase, instead of 10, I do first 50 and run it. I'm getting the value. My value has slightly changed. Okay. Instead of 50, let's go 100 steps and run the code. It has changed very little. Instead of 100, let's do 1000 steps and see. Okay, so initially if when I had only 10 steps, so the error was slightly higher, because now you are doing slight assumption. Okay, so in the trapezoidal, what you assume that in between strip area you compute, right? By considering it as a rectangle. So if the step size is more, that means you are slightly away from your actual value. But once you increase the step size, you will reach more closer to the exact curve value, and after one point it won't change. Okay, so this is what exactly is happening here. So this is how you can do the trapezoidal rule. Let me just quickly check I have done it correctly. Yeah, this is just another way I have represented it here, FA and by 2. So here I have varied the x value based on the I value. Instead, in this for loop, I am directly using the x value from the A and B data. Okay, so it's kind of a same thing, just a different approach to using it. Okay, so this is how you can compute the area under the curve. You can also try the other series also. You can use Simpson's 1/3 rule or 3/8 rule also to compute the area under the curve. You can use the Fibonacci's. This example, I want you guys to try it on your own and see. If you have any doubt, then we can discuss in the next lecture. Now for the plotting part, since we have few time left, what I will do is I will just give you the basic overview of various plots that we can use. So for plotting in the Matlab, you have this many commands. So when you see just normal plot, that means it's a 2D plot. When you see 3 at the end, like plot 3, and here the EZ plot 3, that means these are 3D plots. In the plot command, you provide the value of your coordinates xy, or in case of plot 3, xyz, while the EZ plot is used to create a plot based on the function equation. Okay, you have surface plot, contour plot. So let's look at the example of this plot here. Yeah. So what I'm doing here is, I have have created one plot. One line represents my y is equal to x square. This is this line, right? One line represents my z is equal to x cube. Okay. I think notation I have kept it wrong. This should be cube. This should be square. So now here you can see your y is equal to x cube line, and this is your z is equal to x square line, this red one. Okay, this is how it looks. So what you do in plot command, you provide x and y data and it creates a plot. But if I solely do this plot, then it will provide me a one plot separately. If I want to plot them on two functions on the same graph, then you use the hold on command, right? These are all the things you must have seen in the source video, and I assume other TAs have also taught you this. I'm just reiterating it. To modify the graph, if I don't provide this, let me comment this, control, and if I run the plot again, this is how it will look like. So this providing X label, Y label legend is nothing but modification and better representation of graph that you can do. For that, if you will do help plot, you will find the complete details of how to do plots, how to provide various colors. So if I go into the complete documentation of the plot command, here you can see there are various options that you can check. If you want continuous line, if you want dotted line, if you want in between symbols, what syntax to use. So you just check this out, try it with the various functions. Okay, since there are multiple variations, so there is no specific point to show you all the data, right? Like all the possible configurations, but you can check it out and try to customize graph as much as possible. That will give you the idea how to create a pleasant graph which represents your data best. Okay, so this is just one example for that. Then you have some 3D plot examples also. So here I have given that plot a sphere and a cylinder. So I want to plot a 3D sphere. So for that, because of the time constraint, I'm not going like writing all this command. I have already this file ready. So if I want to plot a sphere, okay, so I either need a spherical coordinates, data in the spherical coordinates, or the Cartesian coordinates, right? So basically when you are plotting 3D plot, you have to provide x, y, z. So in 3D plot 3 or surf plot, here I need Cartesian coordinate data. But let's say you are working in the spherical coordinate first. So for spherical coordinate, we have three data: theta, phi value, and your radius, right? I have represented it as z. So here first I provide the series of theta, phi value, and the radius. Radius is 1. Okay. Then with the mesh grid command, so mesh grid command is useful, which creates the mesh of theta and phi. So if I just write this part only, here what it has done is it has created x and y grid based on my phi and theta value. So these are my phi value, these are my theta value. So it has converted it to a 2D matrix with various combinations, okay, of row and column. So x is a combination of all the theta, while phi all the thetas, while y is the combination of all the phi values. Yeah, here. and then you have this sphere to cart command, SPH to Cartesian coordinate command. So if you will write SPH to cart, this basically transforms your spherical coordinate to Cartesian coordinate, right? So remember there was this one function where where I had asked you to convert Cartesian coordinate to cylindrical coordinate. You already have some command for that, but if so you can use that also. So here we are converting the spherical coordinate to Cartesian coordinates. If I do that, then I have XYZ data in terms of Cartesian coordinate, which then I can plot, and I will get a surface plot which represents my sphere. So you can see this is how it looks like. This is a 3D plot, you can interact with it, you can see, and this is how it's changing. So this is a surface plot. If I can also use 3D plot. X, Y and Z. I will command this and plot it. So this is how 3D plot will look like. So you have multiple data points in between X and Y and Z. It's connecting all and then providing you the spherical coordinates, like a sphere structure. Okay. So this is one example. Again, if you want to understand what exactly surf command is doing, you can do help surf, and it will provide you what it does, how exactly it computes or creates the surface structure, right? Similarly, the EZ plot, it uses an equation as an input which based on the equation given, it creates the plot itself, right? So if I do help EZ, first let's look at the EZ plot. So you have to provide any function equation, and EZ plot will create how that function will look like. But this is for 2D. Same way you have EZ plot for 3 dimension, right? So in that case you have to provide functions for all 3 dimensions. So as you can see here, you have one example where they are providing the functions in all X, Y, Z, function X, function Y, function Z. You can also provide the domain under which you want to work. So I have been given the task, like we have to plot a circular helix between interval 0 to 20 using EZ plot. So if you will look at the equation of helix, I think it was somewhere. I think I haven't saved it, but if you will first search the equation of helix equation. So these are the equation of helix, where your x coordinate is r cos theta, y is equal to r sin theta, and z is equal to 80, right? So if you put this inside in the EZ plot, you will get your helix value, right? Let me show you it. So if you do this, our equation is let's say my r value I'm not providing here, I'm taking it as 1, and I want to do it plot helix EZ plot 3. My first coordinate becomes sin t, function x. I have to provide function y, which is cos t, z coordinate, and the limit in between which is 0 to 20, and this is how my helix plot is like. So based on the equation alone also, you have this EZ plot, which gives you how your function will look like if you know its equation. If not, then you can compute its numerical value and then plot it with the plot commands also. And there are further much customizations you can do to this plot. So I will request you to check it out, see the various examples, and then decide how it works, right? Now I have a quiz here, so I think I still have attendance here. So this quiz I think will take 10 minutes more. Should I proceed with this quiz and finish it, or you want to try it on your own? Since we are at the end of your lecture, it's already 8 o'clock. Should I continue? It will take 10 minutes. If not, then I can finish lecture right now also. Yes, no? Okay, let's quickly look at that quiz part. If there is anything specific, then we can discuss. Okay. So first question is, which of the following is not a correct way to execute a script file? So we have various options. Do you know what is the incorrect way? By pressing the F5, I use F5 to run a script. We have a green run button in the editor window also. File name, we can use file name and write on the command prompt. That also works. Option D, which says run followed by a file name, and option E says the pressing the execute button. Can any one of you guess what is the correct answer? Like, which is not the correct way to run a file? No? So this is actually option E. There is no execute button. You can directly write the file name on the command window and it will run. You can write run followed by a file name, then also it will run. What are the shortcuts to add and remove the comment in the Matlab file? I think you might not know it. So this is Control R and Control T. You can so Control R is to add a comment and Control T is to remove a comment. So if you will select the text and do Control R, it will comment that portion. What is the output of following command? Flow underscore condition, and I have written laminar and flow. So what it will do? Do any of you know? Let's try it. So my variable is flow is equal to laminar flow. If I write this gives me laminar then flow. Sorry, there is no space there. If this is how it gives me, right? So what should be the answer? Should it be this laminar flow, or it will be something else? I think you guys are tired. Okay, so let me move quickly. So actually it will be B, because you can see here I have provided extra space also. So it's slightly tricky. So it's a laminar flow. This will provide me answer in this fashion. Command /n is used in fprintf. So it's generally to go to a new line, right? Find the trace of inverse of a matrix. So it's a 2 cross 2 matrix, so you can do directly also. Inverse will give same diagonal and its trace is 2 plus 2, 4. Right? If you have a 3D matrix, then you can use trace of matrix command and then compute the trace also. Consider the following snippet and identify the mistake in the code if there is any mistake. So it's a for loop which goes from I is equal to 1 to 1000. It has a condition on I. If I is less or equal to 50, it follows this equation. If not, then it follows the other equation. Now, can you spot any mistake? Anyone? Yes? Okay. So see here, it's a if-else statement, right? If this condition is true, follow this, else follow this. So here it should be else, not else if. If it's else if, then I should have one more condition provided here, right? So this thing I can understand is wrong. And then I have written as 2i. Now I is a variable. If I'm multiplying it with 2, then I should have 2 star symbol, which is used for the multiplication. So this is the error. If a break statement is used in a nested loop, it will terminate all the loops, whether the statement is true or false. So actually it's false. So if you have loop, let's say for loop, inside you have further for loop, okay, so you have, this is a nested loop, right? So in the second for loop, if it contains the break part and if it is executed, then only the inside for loop will be terminated. It doesn't terminate your overall code, right? So it's a false statement. Indentation is not necessary in the Matlab. True or false? Actually it's true. So by indentation, what this mean is the spacing that you provide when you write a code. Okay. So here if you will see, when I'm writing the code or a loop, I'm following the spacing. This as one, it serves as a good purpose so that I understand where the loop starts and where the loop ends. So this thing is called as an indentation. Indentation is to start the line at a specific position, right? But since the Matlab identifies this keyword, so you can see it has highlighted if and else if part, similarly and part. So this knows that this particular thing is a one statement, one conditional loop itself. So if I don't provide the spacing in between, then also it should work, okay? Still this thing will run. You can see it's running. It's a complete code. So still it's running, right? So indentation is not needed, but if you will look for some other programming language such as Python, so in Python you have to provide the indentation where you have to start with a specific location. Now which of the following command is useful to plot two different functions in a same plot? So that is C. I think you have already seen in the lectures video of that is by Sir, right? Which of the following command is useful for the labeling, which just saw now, which is X label, Y label. Now which command you will use to plot multiple graphs side by side on one page? Mind you, it's not a multiple graph on the same plot itself, but you want to plot them side by side. So for that, actually you have this subplot command. So if you will go into Matlab and search for subplot command, this is how it looks like. So you provide row and column that you want to put it in your plot. So this first entity, like that corresponds to the number of rows in a plot, and then second is a column, then 1 and 2 are corresponding numbers of plot. So if I execute this command, okay, what it will do, it will the first plot will be plot of income, then second part will be outgo plot. So in a one row, we will have a 2 row. First row will have a income plot, second row will have outgo plot. Okay, so same 2 plots in a same page but side by side. So that is done by subplot. For a vector, so this is a given vector which is made up of, if you will see, it's all the odd numbers 1, 3, 5, 7, 9 till 49. We have to find off sum of twice of every alternate element starting from 5. Okay, so here actually you have to use a for loop where you will start with the condition 5, right, and every alternate element. So instead of using a step size of 1, you can use the step size of 2 in a for loop and compute the summation. I think the exercise that we did should help you to identify it. Right now I'm not writing the code. Do try it. If you find any issue, then we can discuss. Now what will be the output when we call the following function? So it's function plot line MNC. It takes some x value, computes the corresponding y value, and at the end it gives the plot. So it's a plot of a straight line, right, with slope m and intercept c with the plot limit being -20 to 20. This is another example of fprintf, how to control the output through fprintf. So if you want to write the output in this fashion with the if you want to show the power of write the variable in 10 to the power, so for that actually there are just two options. You can start with %small e or capital E followed by your variable, so that will be represented in this form. So that's it for today's class. I think we are above the time, so I will stop the class now. If you have any doubt, we can discuss, else we can end it here and we will meet in the next lecture. So I'm stopping the recording. If you have any doubt, let's discuss.